Come back, students. We are actually in the position zinc. We are discuss on zinc actually. The zinc uses for producing brasses. Okay, and you know that the zinc is principally used in engineering because of its obviously the low melting point is the main criteria for uses in the engineering sector, engineering application sectors, and obviously high corrosion resistance. You know that, and obviously the corrosion resistance actually the corrosion resistance property will come out from the formation of protective oxide coating of the on the surface. Actually corrosion resistance property will be occurred due to the formation of due to the coating of protective oxide coating on the surface. Okay, now main disadvantage is that it is actually most anisotropic in nature in property. Anisotropic, you note that the material should be in two properties: isotropic, that means property will be same throughout all directions, and one term is anisotropic. Now anisotropic, that type of materials it is called, that property is not same in all directions, so property will be varying from one direction to another direction. So zinc is one type of that type of material, that is basically anisotropic materials. Okay, and one more disadvantage is that lack of dimensional stability is also its disadvantage under aging conditions. Okay, so that is the disadvantage portion of the zinc. Now we'll discuss on the next topic, that is basically superalloy. And superalloy, or you can say it is sometimes also called high temperature alloy. High temperature alloy. Okay, high temperature alloys actually. Now as you know that the name suggests that it is not actually only alloy, because we know that the alloy is something like that where the two element are mixed together and they can form and they give the better property from the two other elements when you mix together. Okay, that is basically alloy, but the name suggests that it is a superalloy. Now superalloy means that is sometimes it is called high temperature alloy also. Now high temperature alloy are those alloy which can withstand temperature in excess of high temperature, or in excess of 1100 degrees Celsius. Okay, in excess of 110 degree Celsius. So the high temperature alloy which display, that means at high temperature it gives or it shows or it reflects high mechanical strength property, or you can say that excellent mechanical property or excellent mechanical strength property, and other mechanical properties also like stable chemical composition, and as well as excellent creep deformation resistant property also. That's why it is called high temperature alloy, because the main application of that type of alloy, actually this type of alloy, that it is basically uses in high temperature condition. That's why it is called high temperature alloy. So that is the main definition of the superalloy, that high temperature alloy which display excellent mechanical strength, stable composition, and excellent creep deformation resistance in high temperature condition. Or high temperature means basically that is 110 degrees Celsius also, that is sometimes also called 1100 degrees Celsius also it is exposed. And these alloys are actually used of nuclear plants. It is basically used in nuclear plant. Okay, because you know that the nuclear plants, the temperature is very much high. So in that type of plants, or you can say that the material should be used, that is basically to resist the high temperature conditions. So superalloy or high temperature alloy is suitable for that. Now next property is that the crystal structure of the superalloy material is basically FCC, means face center cubic. You know that the crystal structure is mainly three types. that is simple cubic structure, body center cubic structure, face center cubic structure, or another type of that is called hexagonal closed pack also. Now superalloys are basically FCC in nature, okay, and it is due to the this is basically a wide range of applications. This is a wide range of applications, means it is applications is very much from bottom to top to bottom alloy, top to bottom conditions. That means it is basically because due to the unreal mechanical properties, they are basically uses in wide range of application, from large scale gas turbine, because it is uses in high temperature applications. It is uses in high temperature applications. That's why it is basically uses that in gas turbine, jet propulsion engine, or so note down it. So the as it is wide range of application is that nuclear plant, one point. Second is gas turbine plant, gas turbine. So gas turbine, okay, gas turbine, jet propulsion, jet propulsion, okay. So and small scale components like ball bearing, screw, okay, ball bearing, screw, like that. In that cases also high temperature alloys can be uses. Now main property is that keep resistance, and one more property is a good surface stability. Good surface stability is also its main property in case of superalloys. Now what are the phases present actually in superalloy? That phases are basically gamma matrix, gamma prime, carbide in the form of carbide, in the form of TCPS and grain boundary elements. Now gamma matrix, the continuous, if actually in this gamma matrix, the continuous FCC arrangement of the major element. So matrix, okay, so matrix, the main actually the question is that what is the phases present in superalloy? The main 5 phases are gamma matrix, gamma prime, carbide, TCPS and grain boundary element, okay. Now what are the different types of classification of actually, so what are the classification or what are the classes of superalloys? The classes of superalloys, sometimes it is called iron nickel based alloy, depending on the composition, that is called superalloy. That is incolloy, or it's sometimes called iron nickel based alloy. Next is cobalt based alloy, another is nickel based alloy, okay. Now it is sometimes also called nickel based alloy, it's sometimes also called incolloy, in COLOY, nickel based alloy, or sometimes it is called incolloy. The incolloy basically consists of 42% of nickel, 13% chromium, okay, 13% chromium and 6% of molybdenum. 6% of molybdenum are present, as well as 2.4% of titanium and 0.4% of carbon, and remaining are basically iron, and remaining is iron. So in nickel based alloy, the classes of superalloy, there are 3 types of classes are there. One is nickel based alloy, that is sometimes called incolloy, that the composition of that type of alloy, that is 42% is nickel, 13% chromium, 6% molybdenum, 22.5% nickel, 0.4% carbon, and remaining the portion is iron, okay. Now Hestalloy is the Hestalloy basically nickel based alloy. Another is nickel based alloy. Nickel based also alloy is some example is that Hestalloy. Okay. Now Hestalloy actually just one type of nickel based alloy. The composition is that it consists of 45% nickel. Okay, 45%. Just note it down. 45% nickel. 22% of chromium, 9% of molybdenum, 1.5% of cobalt, 0.5% of tungsten, and 0.15% of carbon, and the remaining portion are basically, and the remaining iron. it is also nickel based alloy. Okay, so the question will come, the example of, give me the example of nickel based superalloy. The example of incolloy and hestalloy. This is most familiar, actually common type of nickel based alloy. And another type of alloy that is called, that is sometimes called vitalium. It is also main constituent is actually cobalt. The main next example is cobalt based alloy. For cobalt based alloy, the main alloy is sometimes it's also called vitalium. VITALLIUM. Okay, vitalium. The main constituent is cobalt. Main base is cobalt. Okay, now it consists of 62% of cobalt. That means as it is base is cobalt, so percentage of cobalt will be high. That is 62% cobalt are there, and 28% chromium. 28% chromium. Okay, 28% chromium, and 5.5% molybdenum. 5.5% molybdenum, and 2.5% nickel, and 1.7% iron, and 0.28% carbon. Okay, so main this is the class was actually covered by high temperature alloy or super alloy. Now high temperature alloy is such type of alloy that which display actually excellent mechanical strength and stable chemical composition and excellent creep deformation resistance. Now what are those properties are there? That is basically FCC in nature, and there is wide range of application, as it is we resist high temperature, as well as it is gives the high temperature resistance, creep resistance, good surface stability. And what are the phases are present? The phases are there, the 5 phases are there that will be present. And what are the example or classes of superalloy? That is the classes of superalloy, mostly important nickel based alloy that is used in case of superalloy. Now nickel based alloy, the example is incolloy and hestalloy, and cobalt based alloy example is vitalium, and another is iron nickel based alloy, superalloy actually. Okay, thank you for listening me, and goodbye.